Great. So we have boiled down to expression B. I still have not got the value of xi that I wanted. How do I get that? We have not yet used the fact that c of x has to be equal to 0, right? So that's the only missing part of the puzzle. C of x is equal to 0 implies that mod of xi should sum to 1, which implies that I have to substitute what was in the previous expression, right? So signum yi and yi minus lambda plus this should sum to 0, right? I is equal to 1 to n. In principle, does this look like an expression that I can solve? Look at each one of those terms. So I'll give you y. It will be a n dimensional vector. That means it has n numbers inside it. Take each one of them. Take y1. Do you know sign of y1? Yes, it's given to you. It will be plus 1 or minus 1, right? Yi minus lambda. So you, and with the plus operator, you can calculate what that is. So finally, what will you get when I add n of these terms? Will I be able to solve and calculate lambda? Yes, it's just a linear one equation, and in each term lambda will come or may not come depending on this plus operator, and you solve it and you can calculate lambda. There is no closed form expression, but it's very easy to solve, right? It's an unusual thing. There is no closed form expression, but it's incredibly easy to solve. So we'll take an example to clarify this. The signum is appearing here. The signum is capturing the cases of, see, because the signum is not being applied to xi, applying to yi. Mod xi is being rewritten as this, no? Oh, sorry, mod of the whole thing. Yeah, you're right. Mod of the whole thing. Yeah, equal to 1. Yeah. So we'll simplify this. Okay. So let's take an example to make this more concrete. So let's take some random. Okay. So this is my point. This is my constraint, right? So this is my, right, 2.3 comma 3.7 is some point over here. And now I want to find out what is the projection of this on the L1 ball. That's the problem. Okay. So there are two terms in this summation, right? Now all of the yi's are positive, so the signum becomes just 1 and I am taking mod of it, right? So actually this signum function will go away because there is a mod around it. So this will simply become I is equal to 1 to n mod of, actually do I need to put mod anymore? The plus operator, does it ever spit out a negative number? It either is 0 or positive, right? So this mod goes away altogether. So I just have mod yi minus lambda plus, when yi is 0, signum makes it 0. No, you won't. Okay, the plus operator takes care of it. Okay, so now this is the expression that I have to work with. Let's plug in one by one y1 and y2, right? So what is, I mean, I can do it like that, but then I don't know how to evaluate the plus operator because I don't know lambda, right? Supposing I put 3.7 and 2.3, I have 3.7 minus lambda plus operator. I don't know how to evaluate that because I don't know lambda. So there's a very simple graphical way again of doing this. Let us take a vertical scale. Let's mark 3.7 over here. Let us mark 2.3 over here. Okay. Now each of these numbers, so you need to pay attention, each of these numbers I am subtracting lambda from it and then applying the plus operator to it. That thing should sum to 1. So supposing I take my lambda over here. Okay, so let's say that this is lambda equal to 3 question mark. So the first term 3.7 minus 3, what is the plus operator going to spit out? 0.7. The next term, what will it spit out? 0. So it does not sum to 1, right? So now imagine that I have a slider available with me and I need to make y greater or larger, greater or smaller. smaller. I need to lower it because the sum is not yet coming to 1. So, supposing I lower it all the way to where? 2.7, right? If I bring this down to, for example, over here, lambda equal to 2.7, then what will I get? I'll get 3.7 minus 2.7, that's 1. Then 2.3 minus 2.7, and the plus operator of that is 0. Done. If I go any further than 2.7, what happens? The first term will become greater than 1, second term will continue to be 0, right? So, there is a sweet spot over here. So, this implies that lambda equal to 2.7 is the correct solution. So, I have got lambda, right? Finally, I need to get x, right? Lambda is the intermediate guy. So, I had that expression for xi, which was signum yi, this expression over here on top only. This was my expression for this. So, what will x1 be? So, sine of 3.7, signum of 3.7, 1 into mod 3.7 minus 2.7, 1, x2, sine of signum of 2.3, 1 into 0. So, the solution is x is equal to 1, 0, right. So, actually this projects to this point over here. Right. So, you got, so we will take one more example, this time with a negative coordinate to further drill this in. So, let us take an example of, let us say 3.7 and minus 3.3. This is the point that I am trying to project. So, which quadrant is this? Bottom, somewhere here, right. I am trying to project this into the L1 ball, right. So, we will quickly wrap up from here. So, first step, right, we draw this over here. Do I need to draw, see, remember there is a mod y in that. So, on the scale, what should I draw? The mod of the yi value. So, the mod of the yi values is going to give me 3.7 and 3.3. See, there is a mod happening over here, mod yi. So, each yi can be negative, it does not matter, it is mod yi minus lambda over here, right. So, what value of lambda do you think will work? It has to be less than 3.3. Supposing I stop at, let us say I take 3.1, will it work? 3.7 minus 3.1 is 0.6, and 3.1 minus 3.3 minus 3.1 gives me 0.2. It still does not sum to 1. So, you can figure out what is the best value of lambda then? 3, right. So, 3. So, lambda equal to 3 is what works, and then you apply the you can go through this exercise and you will get the solution. X1 will be sine of 3.7 is 1, 3.7 minus 3 is 0.7, x2 signum of minus 3.3 is minus 1 into mod 3.3 minus 3, 0.3, right. So, solution is 0.7 minus 0.3, okay. So, this is simple enough that you could actually write a clever enough piece of code that does it. Hmm. Hmm. Yeah. Perpendicular, yeah, perpendicularity does not make sense if the tangent direction is not defined. Perpendicular to what? To any of them, exactly. Okay. So, this I had to rush a little bit in the end because I mean, this topic of subgradients and projection on L1 ball is now over. But this is a new concept for most of you. I think most of you are seeing the idea of subgradients for the first time. And this is particularly if you go more into numerical analysis, it's a very, very important tool. So just go over it once. It's not too tough once you get familiar with it.